Hi everyone, welcome to this week's science lesson. Today I have a surprise for you. We're going to be doing a science experiment. By looking at what I have on this table, can you guess what the science experiment is going to be? I'll give you 2 seconds to just brainstorm and think about it. Very good. We're going to be making a lava lamp. A lava lamp has been very popular back in the day. So around 10 or 20 years ago, everyone had a lava lamp. It's very easy to do, and you can do it at home too if you are bored or if you would like to do something very cool. Okay, so you can buy everything at Big C or any supermarket. So what you can do is get a little jar or a glass, anything that is clear so you can see the lava lamp. Okay, so over here I have a jar, I have a glass. I also bought some cooking oil. Any cooking oil is good, but the clearer the better. Then I also have some water. So we're going to be using some water. And we're also going to be using some food coloring. So we've got red food coloring and some green food coloring for today's lava lamp. And lastly, I would like you guys to also get some Alka-Seltzers. So Alka-Seltzers is a fizzing tablet. You can find it at any pharmacies. Okay, fantastic. Okay, to begin this experiment, take your water, then pour it into your jar or your piece of glass. So what you're going to do is you're just going to make it at 25% in each one. So 25% of the glass. Perfect. So your jar is full at 25% with water. Then afterwards, what you're going to do is you're going to take your cooking oil. Remember, you can use any cooking oil, the clearer the better. And then you pour it in. And you can pour it all the way to the top. Okay. But as you know, oil and water will separate. Okay, just pour it in there. To the next one. Even if you don't have these measuring tools, it's okay. You can still do it from home with just pouring the oil directly into the glass. Okay. Perfect. And the last one. Okay. Okay, I'm going to explain to you in a moment why water and oil does not mix together. Okay, just a little bit more oil. Okay, fantastic. So at this moment, you have oil and water. So what you're going to do now is you're going to take any food coloring. As I said, we got red and green today. And because food coloring is majority water, it will sink to the bottom to the water. So what we're going to do is we're going to just wait for the oil and the water to separate. Can you see how it has separated? Fantastic. Okay. So now you're going to pour the food coloring. You You can add 10 droplets to as many droplets as you want inside. Okay, so let's put 10 droplets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. And let's make this green too. 3, 4, 5, 6, 7, 8, 9, 10. So it really doesn't matter how many droplets you put in. Okay, fantastic. Then we're gonna put a red food coloring into the middle glass. Okay. Just took a little second to open. Very good. And let's put in 10 droplets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. Okay. And what you can do now, just do this. So it stirs with the water. Stirs with the water. And this one. Okay, so what you'll do is you'll let the food coloring mix with the water and not the oil. Fantastic. Okay, now the last thing you do is you get your Alka-Seltzer tablets. Your Alka-Seltzer tablets you can get at any pharmacy. What you do is you just make sure that it's separated. Fantastic. You can take a tablet. Open it up, put it down. So just one tablet will be enough per lava lamp. Okay. What you can do is you take your Alka-Seltzer tablets, you drop it into the water and you watch it sink to the bottom. And then you let the bubble experiments begin. Let me show you. So what I'm going to do is throw each in one. So it's going to start fizzing. Okay. So this is your very own lava lamp. Wow, how amazing is this? Fantastic. Okay, so to begin, the oil stays above the water because oil is lighter than water, or specifically as we say, it's less dense than water. Density describes as how much space a substance or object takes up, okay? So when you add the tablets, it sank to the bottom and started dissolving, creating gas, as you can see. As the gas bubble roses, the bubbles took some of the food coloring with them, as you notice up here. When the bubbles of the water reaches to the top, the gas escapes and down the bubbles go. Isn't this very impressive? Wow, this is very cool. By the way, you can store your colorful bubble bulbs in a jar or a bottle with a cap on, and anytime you want to bring it back to life, you just add another Alka's tablets. So what you do, you can store it and just close it up, and you have your little lava lamps for next time. Isn't this cool? Okay, so what I can say is I'm definitely going to save these lava lamps. I'm going to close them up and take them home. If you want to even make it more impressive, you can use a torch lamp or use your phone for that. Okay, in modern day we have torches on our phone. How crazy is that? So what you do is you switch on the torch, and then you can put it underneath. Let's put one more Alka-Seltzer tablet inside. And there we go. You have your own very own lava lamp. Okay, so as I told you, I'm gonna take these home and then keep them to show my friends and family. If you're bored and want to do something cool, then the lava lamp is a great science experiment. You don't need much, okay? So, as I said, all you need is cooking oil, Alka-Seltzer tablets, and water and food coloring. So thank you so much for watching the science experiment, and I'll see you next week and in the class. See you soon. Bye-bye.
Hi guys, good morning. Welcome to science video. Teacher Ollie in the last video showed you how to make a lava lamp. So I hope you managed to do that and you had some fun. We're going to actually have a look today about the science behind why your lava lamp worked. Okay, so could you tell me what a chemical reaction is? Because in your lava lamp, when you made it, when you started to get the bubbles, then there was a chemical reaction happening. Can you actually remember what a chemical reaction is? Try to have a think. Okay, a chemical reaction is a process that produces chemical change, resulting in new substances forming that are different from the original substances. Chemical reactions include reactants. They are the things that we begin with, and those reactants produce products. Those are the things that we get after the reaction has happened. For example, if you look at this graphic here, we have CH4, that's methane gas. If we add oxygen to methane gas, that produces a chemical reaction and then makes carbon dioxide and water. So methane gas plus oxygen produces carbon dioxide and water. The reactants are methane and oxygen, and the products are carbon dioxide and water. When you made your lava lamp, you had Alka-Seltzer. Now, Alka-Seltzer is mainly made from sodium bicarbonate and citric acid. When those two chemicals are mixed with water, the reaction is exothermic and carbon dioxide gas is generated along with sodium citrate. If we take a look at this slide and we start with the ingredients of water, which we know is H2O, and Alka-Seltzer, which is sodium bicarbonate, we can see that is made up of sodium, hydrogen, carbon, and oxygen. And we have citric acid, which is made up of carbon, hydrogen, and oxygen. When we add Alka-Seltzer and water, we have these substances. This one is the Alka-Seltzer, and this is the water. They react, and then they produce water vapor, which we have here, carbon dioxide. The carbon dioxide is released into the air. We have sodium citrate and water, and they remain in the beaker or in the glass. So this is the reaction that we get: water vapor, carbon dioxide, sodium citrate, and water. So what happens here is that the carbon dioxide gas makes bubbles which rise to the top of the glass, taking some of the coloured water with it. When the CO2 reaches the top, the bubbles pop and carbon dioxide is released into the air. The coloured water sinks back to the bottom. Earlier I said that the reaction was an exothermic reaction. Can you remember what an exothermic reaction is? I'll give you a clue. If you hold your lava lamp as the reaction is taking place, do you notice a change in temperature? Does it get warmer or does it get colder? What kind of a reaction is the opposite of an exothermic reaction? Try to think about that too. Exothermic. What is the opposite? Okay, I think you may remember this slide. If we have a look here on the left, exothermic, this type of reaction, produces heat. So the substances inside the reaction will get hotter. Try it. Feel your lava lamp and see if you can feel the temperature rising. The opposite of exothermic is endothermic. And what will happen there is that the substances will get cooler. They will cool down and become cold. Why don't these liquids mix together? Can you remember that? In your lava lamp, you have water and oil. In this picture, we have water. We've got it colored red here. And above that, we have oil. But they are not mixing. Can you remember why they don't mix together? Think about it. If you said it's because they have different densities, well, that is great. Each of these liquids, the water and the oil, have different densities. So, for example, if we look at different states, gas, liquid, and solid, they have very different densities. But if we're just looking at liquids today, liquids also will have different densities. A more dense liquid will sink to the bottom, and a less dense liquid will remain above that at the top. So can you answer the following questions? Number 1, what is a chemical reaction? Number 2, why doesn't the water and the oil mix together? Number 3, what is the opposite of an exothermic reaction? And finally, number 4, which gas is released in this experiment? So thanks for that, guys. I hope you've had fun making your lava lamps, and I hope you've had time to think about the chemical reaction that is taking place. Think about any questions that you might have, write them down, and we can discuss them in our Zoom call on Friday. Take care, everyone. Bye-bye.